There we go. Okay, so I will break it down for you. In this unit, there will be three main parts. Okay, today we're gonna focus today and tomorrow probably triangles mostly. Then we're gonna deal with quadrilaterals, so four-sided polygons, quads, right? And then after that, we're gonna go polygons. This is like many-sided, so some of the, like if I say pentagon or hexagon, and above that, we're going to deal with that at the end. Okay, so those are the three main parts of this unit, and geometry gets bunched up with trigonometry on the exam, right? So there's not a single geometry section, there's trig and geometry combined. Okay, so let's go and explore this a bit more. Some review. I know this is a review, but hang in there because I need you to understand this before we continue. Okay, so the first thing I want you to remember is symmetry. Symmetry is only pertains to isosceles and equilateral triangles. And what I really mean by that is that you can split them in half because they are symmetric, right? They are symmetric. Like when it comes to isosceles, equilateral, you can split them in half because they are symmetric. So here are some examples. So you've got this triangle going on here, and I need you to emphasize the sides. So if you notice that two sides in this case are exactly the same, we can also use markings for that. We can say, hey, this side, it has the same measurement as this side. Okay, what kind of a triangle is that, by the way, if two sides are the same? Isosceles, yes. And isosceles is symmetric. Okay, we can cut it in half. What in the world do you mean by that, Mr. Dirksen? Quite often, it's going to be beneficial to cut this triangle, and we'll call that the height of the triangle, right? From the highest point right down to the base. So that's our height. And we want to transfer as much information to this one as possible. So the 50 here would for sure come over here, no problem. Okay. And what else could we bring over? Well, this 80, because it's symmetric, we can actually say, well, that 80 is going to be split in half, and that's going to give me the 40 here. Yeah, I used a different color for things that are new, appearing new, right? Use a pen or something. And I could also, with this 70 up here, I could take that 70 and just split that in half, right? And then say, well, this angle here is 35. And the last thing that I often forget to add to my diagrams, but it's very important, is to know that you have a 90 here. If this is indeed the height of the triangle, then there's a 90 here at the base. Okay. So you've actually been able to transfer quite a bit of information to this right triangle here, and because this is an asymmetric triangle. Okay. Next, we have this one, and what do you notice about that one? If you look at the numbers or markings are going to be important for us. Yeah, they're equilateral. It's all sides are the same. So I'm going to also put markings down. So this one, and this one. So all three sides are the same. Equilateral. Symmetric. So let's see what we can bring over here. So if you look at this triangle, I think the first thing we could do is bring that height there. Bring in the 90. We could take the 100 because it goes from side to side. We could bring that over and just divide it in half, and then you get 50 centimeters. This side over here, the 100 just comes with you. Is there anything else we could have done? What do we know about equilateral triangles? All their angles are the same, right? Let's go back to the original. So if all angles are the same, we can go 180 divided by 3 and know that 60 degrees each angle. I'm just going to write that down here. So this is 60, this is 60, and this is 60. Okay? All three angles are 60 degrees on the original. So I can indeed bring this one over, split it in half, right? Because that 60 gets split exactly in half. You get 30 there. And then this we can either just find out by looking at what's in here, or just transfer this 60 over, and you've now created a right triangle with a lot of information that you can use to answer further questions. So I know this is review. For some of you, it's just like, I get it, right? But I want everybody to be on the same page. What about this one here? Here you would have to say, if you look at the numbers and the shape, of course. Hello? Okay. Let's keep going. So this one, you see all sides are different. Watch this. The markings is what I want you to be after here. This would get 1. This would get 2. So we're saying these are different. And that third side, I would put something like that down. For sure, guys. For sure. If the markings would have to be different in this case. Something else would be different. If all three angles are different, so are all the angles. Did you know that? Do you remember that? I can guarantee you that this angle, right, will be different than the one you're already given. And this third angle would also be different. So watch how I do the markings. This has 1 line, 1 arc, 2, and then 3. So there you have it. So I'm kind of introducing markings at least. So that is called, anybody know what a triangle is called where all sides are different? Starts with an S.
Scalene.
Scalene, yes. Scalene. I will say this right away. All sides are different. All angles different. That's what a scalene, the definition of a scalene is, everything is different. Okay. Okay. Anyways, if we were to cut it along this dashed line here where the height is, this resulting triangle would get a 90 here. But we have a problem here, and I see that all the time. This 100, you cannot divide by 2 to get 50, correct? That would be wrong because this is not a symmetric triangle. That's why there's an X here. So let's just write wrong here at the very side. This 100, you can't just divide it by 2 and say 50. That's also wrong. Okay, so this is wrong, that is wrong. You can't do that. Okay, so I'm going to put down at the bottom here, not symmetric. So something to be aware of. In that case, we couldn't just do that. We would need more information. Let's keep going. This is You know what? This is going to come back later, so I'm not going to spend a whole lot of time. I just wanted you to be aware of that. Page 3. I want you to look at the original triangle and then try to find as much as you can in here that you can fill in based on what you're given, and then transfer information onto this one here that is being cut. Okay, so you look at this one. There is information there, by the way. Hint, hint. There's more that you can find out about it, and then bring it over here. Transfer as much information as you can. Same with this one here. Use a pencil, please. Do not use a pen because I will go over it with you. But I want you to practice that already. You know a lot about triangles as it is. So can you fill in the left side and then transfer stuff over to the right side? Okay. I'll give you a bit of time. I'll do the attendance. All right. Let's see how you did here. So you have to go back and see what you already know about triangles. There's a lot that you already know about. Okay. So grab a highlighter. I would like you to notice that right off the bat. That's an isosceles triangle right there. Okay. And what else do you see there? It's kind of cut through, but do you see this 90 here? You see that? If that is 90, and I know some of these things might be a little new to you, or you're like, I kind of remember, but this is I didn't think of it right away. But these two sides will have angles across from them. Let's go dashed lines like this. Okay. Well, if you go across those sides and you get to the angles that are opposite to them, those will be exactly the same. Okay, they'll be exactly the same. Make sure you follow along. How could we find out what these angles are?
180, and that's the right triangle, so it's 90, so it's above 45.
Right, like if all of them are 180 and this is 90, then these two should be 90 as well, split 90 in half, right? So I will show you this way. I'll go 180 minus 90. I'll put that in brackets like that, and I'll split that in half. So you get 90 divided by 2, which is 45 degrees. Okay. So this is 45. I'm going to try to just write it in there, okay? That's 45 degrees, and so is this one. There's actually a lot of information that you could have found out about this one here. Okay. So this is still h, this is still height. Can I split this in half to get the top here? Yes, I can, because there's a symmetric triangle. So this would be 45. This is 90. This, I can just copy this one over and get 45 here. Okay. I could have either just said, hey, if this 45, this 90, let's use sum of 180 to get this one, or bring it over and just insert it there and you're fine. So that's all you could do based on what I gave you there. Okay, there's not much you could do there. Okay, next one. Notice the sides. Okay. If there's a 7 associated with this mark and you see 1, 1, 1, we for sure know this. Right? We can fill in all three sides with 7 centimeters. What else do we know about the angles? We already did that previously. If it's an equilateral triangle, then all angles are 60. Okay? 60, 60, 60. That one can be split. Okay, so this is height. That would be coming right down the middle. So I can take that 60, split it in half, and get 30. This would be a 90 here because if it's my height, it has to be 90. And then I can just take this 60 and plug it in here. What else can I do in terms of the side lengths? Well, this 7 comes over here, no problem. Okay, 7, it's the same length. This 7 will be cut in half, right? You're splitting it in half. And there you go. This triangle actually had a significant amount of information that you could have transferred over just the way it worked out, okay? So remember, try to see, look at the markings, look at what you know about the triangle. If it's equilateral, it's 60 all around, okay? So, yeah, go ahead. One more thing. These formulas here, are not on any formula sheet or anything else, so they do show up. So I would encourage you to add that to your study sheet. These are formulas for the areas of the various shapes. Area of a triangle, I think everybody knows that one, base times height divided by 2. Area of a parallelogram would just be base times height, right? Base times height, height goes right across. And the last one here is the one I want to draw your attention. You're going to see quite a few of those. I want you to notice that if you look at the formula, it's a plus b. It's like the short side plus the long side. You got to first hit equals there, then multiply it by the height and divide the remainder by 2. Okay, so you got to be very careful how you calculate that. Does it show up a lot? Not a lot, but it does show up from time to time. So I would say study sheet. Here, I would say add it to your study sheet. So just write things down that I'm talking about so that if you review this booklet, right, you can be reminded. It's going to be a lot quicker than if you have nothing written down, okay? So Pythagorean theorem, I'm going to review that real quick. I'm going to give you the shortest lesson on Pythagorean theorem, the shortest way, the quickest way of doing that, okay? So I'm going to highlight that. Lets me know that I covered this. Only works with right triangles. Remember that. It only works with right triangles. It doesn't work with any of the other ones. So the first thing here, the key is if you have a 90-degree angle, the side across the 90 is what we call the hypotenuse. The other two are called the legs. Okay? So make an arrow going across the 90. Wherever the 90 is, just travel across. That's what we call the hypotenuse. Because I don't care about A, B, C, or whatever letter is in there. I care about you knowing which one is the hypotenuse, which ones are the legs. So here it is. You ready? If the hypotenuse is unknown, I use this formula. Hypotenuse is taking the square root of the first leg squared plus the second leg squared. That's all it is. Using ABC actually makes it confusing because what if A is a leg on one question and it's a hypotenuse on the other one? You're not right, like you might mix things up. Just call it this. If a leg is unknown, right, if you're trying to find the leg, you just go, okay, leg is taking the square root of the hypotenuse squared, and here's where I'm going to use a different color. It's not plus, it's minus the one leg that is or known, I should say, and that's basically the main difference between one or the other. You're going to get to practice this in a bit. I just want to make sure you know how to do it. If you know how to do it, you're going to be in very good shape. So let's keep going here. Let's put this into practice right away. You're with me? So interesting, right? You find the 90-degree box. You go across from it. What's that one called? Hypotenuse, right? That's my unknown here. Hypotenuse is unknown in this case. What does that mean? It means that these are my legs, right? Leg and leg. So in order to find it, watch this, right? Out of these two formulas, you'll be using this one because you're trying to find the hypotenuse. So hypotenuse is going to be 7.6 squared plus 9.4 squared. Right? Basically squaring both legs, and then we're going to add them up. On page 4. So grab your calculators. I want to make sure you know how to do this. 7.6 squared plus 9.4 squared. Can you see that? I use the X2 button. I don't know what buttons you're using. You may have to use that little hat or the Y to the X or something, but square it and add. And I hit equals. You should get 146.12. I don't want you to round. I want you to use all decimals. Okay. And now let's hit the square root button. Square root equals, that's what I have to do, and that's 12.09. Okay, so the hypotenuse is 12.09. And because you've told me on the original diagram that you're calling side A the hypotenuse, you're fine to just leave it like that, right? Because you've already told me I'm finding A, essentially side A. One more before I hand it over to you. There's 3 questions on the back of this where you're going to quickly practice your skills, okay? Let's look at this one, guys. Find the 90-degree angle. Oh, by the way, Pythagorean theorem, you need a right triangle. And you need 2 out of the 3 sides for this to work, okay? So I find the box, I go across. This is the hypotenuse, which means this is a leg and this is another leg. And in this case, the leg is unknown to you, right? So we go like this. Leg is going to be, it's always square root, always. Square root of my hypotenuse squared minus the leg squared that you have there. And let's grab our calculators and just try that. See, the best way to stay awake is to actually just follow along. If you just listen to me, it's like, whew, bedtime story. 15808. Is that what you're getting? 15808? So watch this. It's not the answer yet. It's not the answer yet. Now I have to press the square root button, and that is my final answer. It's 12.57. What are we in inches? Inches. Boom. Just like that, guys. Just like that. It'll be very quick. So go to page 5. Try those. This is not the meat and potatoes yet of today's lesson. This is just getting you ready for it. Go to page 5. Try those 3. The answer is at the bottom corner. I don't know if you see it. You just have to flip your booklet to see the answer. So give it a try, okay? Just keep going for now. Thank you for trying. I appreciate that. And you should thank yourself as well because it's going to help you. On page 6 now, I think the main point here on page 6 is that we're going to classify triangles. And when a question, I hope you don't miss this, right? When a question asks, right, what is like classify a triangle, you really are supposed to, this is just me, I just came up with this, like give it a first and a last name. That's basically what the question is asking. Right? Classify means give it a first and a last name. And by the first name will be this part right here. So we're going to say that the triangles, by classifying it by angle measure, will be the first name. And you have three options there: acute, right, or obtuse. The most obvious one there, and I'm going to highlight that one, is as soon as that triangle has a 90, like you determine that there's a 90 or there's a box, it is definitely going to be a right something. Okay, so this is going to be the first name, one of these three options, only one. Okay, and then by side length, like you also classify them by side length. So this is the last name. But really, I don't care if you mix them up. If you give it the last name first and then the first name second, like it to me, it doesn't matter, and you're not going to lose any marks. Okay. So you will have to give it a first name. So one of these three categories, and you will have to come up with a last name, which is one of these three categories. So the triangle can either be equilateral, isosceles, or scalene. Okay. And I'm going to highlight these things here. Equilateral, I guess I'm going to write it down next to this on the side here. Three sides are congruent. I don't know if you've ever seen this symbol. Have I ever used this with you? Equal sign with a third wave. Okay, I'm going to just tell you that that means congruent. Or equal. It's the same thing. But I'm going to use congruent down the road. So I want you to know that. And it's so much easier than to write down congruent. Okay? As well as three angles. And I want you to look at the pattern here. If all three sides are the same, then all three angles will be the same. Okay? I can tell you, hey, I have a triangle with where all three angles are the same. You should be thinking, I also know all three sides are the same, and vice versa. Okay? Isosceles, you guessed it, two sides that are congruent, and therefore two angles that are congruent. And you might think as trivial to write this down. It's like, nah, I know this already. But sometimes students overthink it and they miss the point. Right? So if I tell you two sides are congruent, you also know, okay, we'll have two angles that are congruent. And I want to make the arrows thing again. So, right, there's a relationship between the side and the angle across from it. Okay, every time. And then the last one is the scalene, which I used earlier. No angles are congruent. No sides are congruent. Okay. So that's just not happening. Out of the three here that you were able to choose here, this one is not symmetric. Not symmetric. Sorry. These two are symmetric. This one is not symmetric. The scalene is not. Okay. And this question that I'm asking you there, just below this whole thing, actually came up on an older provincial exam. And I like the question. So why can't a triangle have more than one obtuse angle? So we know that a triangle has three angles. if you want a triangle to be obtuse, it has to have, right, an angle bigger than 90. If you end up with another angle that's bigger than 90, right, if like two obtuse angles, this already adds up to 182 degrees, correct? This cannot be true since since the sum is always 180. So like if you have more than one obtuse angle in your triangle, this C no longer has anything, but you need three angles, right, for that triangle to even be a possibility. So that would be one way to explain that. I think I didn't emphasize this one point here. One second, I'm going to go back up. Just write this down. I just focus on the right triangle, not the acute or the obtuse. Just want to make sure you understand that. So I'm going up a bit here. Maybe I should re-emphasize the whole triangle would be considered acute if all three angles are less than 90. So 90 is kind of like, okay, if it's a 90, then obviously we know it's a right triangle. But if all angles are less than 90, it's acute. If one angle is greater than 90, you have an obtuse case. And I hope you all know that the greater than 90 in this case would be located right there. You can only have one obtuse angle. Remember that. You cannot have more than one obtuse, because then it would no longer be a triangle. Be more than 180. Okay, so let's practice this now. Let's practice classifying triangles. And I mix it all up. You're gonna use, you might have to use Pythagorean theorem. You might have to use sine law, cosine law. Today, I don't think you have to use sine law, cosine law, so don't worry about it too much. But down the road, right? Go ahead. Let's go to page 7 real quick. Page 7. I'm just letting you know that these steps, I don't know if you need to put this on your study sheet. It takes up a lot of room, to be honest, because some of you are just naturally gonna know what to do. You're kind of just gonna try things until you figure it out. But here's the steps to classify. Okay. Look for side lengths or angles given. It could be markings or actual values. So that's step number 1, just observe. Number 2, can you calculate any missing sides or angles, right? You can use Pythagorean theorem, the fact that the sum of triangles is equal to 180, or on a more extreme scenario, you're gonna have to use sine law, cosine law to figure it out, okay? 3, conclusion. All angles, sides are different, right? It will be for sure a scalene. You're gonna have to narrow down, is it acute or obtuse? 2 congruent sides or angles, then we know for sure that it will be an isosceles. And if all angles are congruent, then you have yourself an equilateral triangle. Okay, and an equilateral is always acute since all angles are 60. They're all less than 90. So there's no need to say acute equilateral if you don't want to. Okay, so let's let's try this out. See if you can do this. And some of them will take you seconds. Some of you will take you a little longer. Okay, so let's look at this one here. Just making sure my notes are up front. Let's observe. We look at markings. Okay, I'm going to use orange for this one. If I look at the sides, right, and I give it a first name and a last name, and I won't do this every single time, but one of them is if it's asking you if it's a right, acute, or obtuse. On the other hand, we're supposed to say whether this is an equilateral. This is on page 7, equilateral, isosceles, or scalene. Scalene. I kind of butchered that a little bit. I'm going to zoom in just to that one there for now. Okay, so all you need to do is give it a first name, give it a last name. So these are your choices here. I don't know if you want to just have that in your study sheet. When it comes to classifying, pick one from here, pick one from here, and you have classified that triangle. By picking, I mean don't guess, okay? I mean based on your conclusions. So based on the orange part is going to go here, the side length, and the angles is going to go here. What is this based on angles? Maybe that's the easiest one to do. There's a right angle right there. So we're going to call this right. Right? Right. And then by side length, which is these three here, what would we call it? All three sides are different, so this is scalene. That's how easy, like I made it way too complicated, by the way. This would have been a lot faster, but I'm trying to make sure you understand what it is that you're supposed to do here. You don't have to use highlighters. You don't have to write down all three for each one. Just tell me a first name and a last name, and you're good. What if you wrote scalene right? That's fine. Like I don't care. But you can't do this. I've had some of these scalene isosceles. You're picking from the same category. You can't do that, right? It has to be one from here, one from here. Okay? So let's try B. What is this? This is equilateral. Like all three angles are congruent. That's just my justification here. This is an equilateral. Yeah, that's it. I will just put like a little star. No need to mention acute. Okay, you don't need the acute in front of it because by definition an equilateral has all angles 60. Doesn't hurt, but it is what it is. Let's try a different one. Let's try C. First name and last name. I'm just going up here to help me out. Oh, is it which one of these three is it? It is right because you have that there. So I will use the highlighter part. So based on the angle, this is a right triangle. Based on the sides, this is going to be an isosceles. And I'm going to use my orange highlighter for that one. Just mentioning that that's what I based my decision on. But I have to warn you here, because I think everybody would have said, yeah, isosceles for sure. But what if, because this is true, okay, what if this question, all it would have given you is this, which is true. You can go ahead and add that, okay? If all the question had done is given you the two angles, you still would have concluded that it's isosceles. Because if you have two angles that are congruent, you're guaranteed that these sides will also be congruent. Like it's just a fact, okay? So sometimes it's the sides they mark, sometimes they just give you the angles there, okay? So keep that in mind. Last one. Crickets, crickets. I hope that you're tempted. If you look up here, I hope you're tempted. It's like, oh, I've got 2 out of the 3. Can I find the third angle? Let's do it, okay? So I'm going to find third angle here. I'm going to tell you this. If at all you can calculate, calculate, okay? So what should we call that? Angle A? Angle A is 180 minus 30 minus 20. What do you get there? 130? Yeah. That's 130. Right, let's write that into the diagram. And why was that important to figure that out? Because now we know what kind of, in terms of angles, it will be, let's go back up here, it will be an obtuse triangle. Okay. So I go like this, and say it's obtuse. And what is it based on side length? Hold on, I need to get my highlighters right. This is here. What is it by side length? Take a risk. It's okay. I won't bite. Side length. If I had to give you a mark for it, would you put equilateral? No. Why not? Well, they have to be 60. All of them have to be 60 for that to be true. What about isosceles? You don't even have two angles that are the same, right? They're all different. All 3 angles are different. Therefore, it's a scalene. Okay? Scalene. So I want you to feel free to do this. Because all 3 angles are the same, I know that all 3 sides would be, did I say all of them are the same? Sorry. Because all 3 angles are different, so are the side lengths. Guaranteed. Guaranteed. I will make a note here. I'll try to fit that in. All angles are different. Therefore, all sides are different. And the reason why I write this down is because sometimes students are like, well, there is no side length. I can't possibly give it a name because I have no side lengths. Just look at the angles. If they're all different, then you know all the sides are different. You don't need to actually know what they are. And I'm going to stop right here. This is it. But you still have 15 minutes. I would like you to at least use 10 out of those 15 to work on the pages that I'm about to tell you about. I'm going to leave this up here. How about I write this? You can write this on page 8, at the top of page 8, okay? You work on pages 8 to 11. 8 to 11. You can write this down on page 8, right? Because it's a little cramped here. And I will post the key in a bit. And what I need you to do here is, to the best of your ability, give every triangle a first and a last name try to show me work or try to show me that you're doing something if at all possible, right? Don't just guess. I would like to see that you came up with missing values if at all possible. Sometimes it isn't possible, okay? So that's it for today, guys. Thank you very much. The key will come up soon, so if you want to check, if you want to ask me questions.